Magnetic effect of electric current. You might have seen the doorbell of your house. When a guest comes and rings your doorbell, you can hear the sound and you can make out that someone has come. Did you know that a doorbell makes use of the magnetic effect of electric current? In this lesson, let us learn about magnetic effect of electric current. Magnetic effect of current. In 1820, Danish physicist Hans Christian Ørsted observed that current through a wire caused a deflection in a nearby magnetic needle. Ørsted placed a compass near a wire attached to a battery. As the electric current flowed through the wire, the compass needle kicked. Ørsted had shown that an electric current generates a magnetic field, and this is called electromagnetism. Let's understand the magnetic property exhibited by electric current using a simple circuit. Here is an iron nail on which we have wound a length of copper wire. We can see that this nail does not attract these paper clips. Now let's attach the ends of the copper wire to a battery. When this setup is brought near the paper clips, we find that the paper clips are attracted by it. Isn't this amazing? Now let's understand why this happens. Let's consider this iron nail. Let's look into its atoms and see what is happening there. We can see that inside the iron nail there are many electrons, which are tiny magnets. Each of this is pointed in a different direction. Hence, there is no magnetic domain, and the iron nail does not show any magnetic property. Now let's see what happens to each of these electrons when current passes through this. When current passes, these electrons get aligned in the same direction and the nail becomes magnetic. Connect the following apparatus: copper wire, key, battery, and a thick sheet of cardboard wire with a hole at its center. Arrange a copper wire, key, battery, and a thick sheet of cardboard with a hole at its center. The iron filings arrange themselves in concentric circles around the conductor. This is because the electric current produces a magnetic field around the conductor, and the iron filings, being magnetic in nature, align themselves in concentric circles. Repeat the experiment by reversing the direction of flow of current. The iron filings arrange themselves in concentric circles around the conductor, but in the opposite direction. This is because the direction of magnetic field changes when the direction of the flow of current is reversed. In this demonstration, we have seen the pattern of the magnetic field lines formed in a current carrying copper wire and their direction. Here are some questions which you may have often thought about. Do you know how an MRI scan works? Do you know what maglev trains are? How does a maglev train work? How are customers identified in ATM machines? MRI stands for magnetic resonance imaging. This type of scan uses magnetism to build up a picture of the inside body. An MRI machine has a large superconducting magnet through which electricity is passed. The magnetic field aligns the hydrogen atoms in the body to get an image of the required organ. A maglev is a high-speed train that runs using powerful electromagnets. Maglev is short for magnetic levitation. A maglev train moves forward due to the magnetic field created by the electrified coils in the guideway walls and the track. On most modern ATMs, the customer is identified by inserting a plastic ATM card. The stripe on the back of a credit card is a magnetic stripe, often called magstripe. The magstripe is made up of tiny iron-based magnetic particles in a plastic-like film. By moving the strip back and forth over the red head, voltages are induced in the coils, and these can be amplified and recorded electronically so that the information can be sent to a computer. In this lesson, we have learned the concept of magnetic effect of electric current. Now, we have some questions for you to think about. What happens when a conductor moves in a magnetic field? If electric current has a magnetic effect, why does it not attract a piece of iron? Find the answer yourself.